Today is a quiet Sunday. Let's do something that some would call controversial. What do I mean by controversial? Well, in this case, it's the subject of restoring tube-era paper-filled wax-coated tubular capacitors, fondly known as waxies. And here are some examples here. YouTube has ample content documenting these capacitors as being unreliable, mainly in that they leak. When I say leak, I'm referring to electrical DC current leakage, in effect turning the capacitor into a high-value resistor. This results in the radio set either becoming noisier or causing actual damage to vacuum tubes from an effect known as red plating, where the grid bias voltage becomes higher than the circuit was designed for. Excessive current flows in the tube and its life is shortened while also running hotter. It can also take out the power transformer, as is seen here with this RCA Victor model A23 from the mid-40s. These capacitors fail as a result of the electrolyte-infused paper insulator inside taking in moisture and acidifying to become semiconductive. Moisture gets into the cap, typically from the ends, where the leads exit the body of the cap, and in some cases like this, the end cap is actually damaged or pushed out, causing the environmental seal to be broken. Even newer plastic shell capacitors can suffer the same fate when the plastic seal surrounding the lead wire fails over time. A good source of additional information on this for those that are interested would be Mr. Carlson's YouTube channel. Now, most restorations will undergo a recap by removing all of the old original wax capacitors, and in some cases even some newer old capacitors from previous repairs, like this Sangamo plastic shelled paper capacitor. And replace them with newly purchased capacitors, like this Illinois capacitor. Or a Duvalier orange drop. This radio is fixed, but this restoration can be perceived to be spoiled by the impact of the new capacitors in the point-to-point wiring, which is how we get to the controversial part. Now, I'm not saying that a modern recap is bad, but there may be cases where the radio restorer may want to keep the original appearance of the radio, even in its electrical circuit. Most times this change is hidden inside of the chassis, but some capacitors may be seen from the back, like in the case where capacitors are being used as a DC blocker on the back cover holding the antenna loop. I decided to try to come up with a solution where the looks of the radio are maintained while modernizing the capacitors to restore operation and make the radio safe. I'm in the middle of a restoration of this RCA mid-40s 4-band tube radio. As you can see in this point-to-point wiring layout, it looks like only one of the original capacitors have been replaced with this one. In fact, all of these waxies have been restuffed and placed back in circuit. One aspect that makes the capacitors seem out of place is that they're typically smaller than their ancestors. However, the radio point-to-point wiring was originally laid out, taking into effect the length of the original capacitors. Replacing them with new equivalents tend to show a lot more space around the capacitor, and the lead lengths need to be longer in order to reach the original tie points. This is a rebuilt capacitor. Prior to inserting the new core, I add a foil shield to the outside in order to ensure that one side is well shielded, as identified on the capacitor's tubular body by this black band here. These caps naturally have a shielded side, but sometimes this can be hard to ascertain. I guarantee the shielding by adding the foil with an additional electrical installation from a layer of Kapton tape. The addition of the shield may add a tiny bit more capacitance, but not enough in my opinion to really matter where these capacitors are used in circuit. This would be in DC blocking, low pass or high pass filters. These waxies are not typically used in critical timing, such as forming part of a tank circuit. I've tried several different techniques when restuffing the caps. In one case, as shown here, with these white ends, this is actually a two-part epoxy, a putty that's just used to seal the ends, and then I re-wax the cap. In this one down here, I tried out using hot glue to seal the end. Now, this may not be such a good idea in cases where the chassis gets hot, such as close approximation to a tube, which is generating a lot of heat. So in the end, I will probably stick with using a high temperature epoxy. And I think you can get better results where the end of the dome here on the capacitor is much easier to form than it is with hot melt glue. When doing the work of stripping out the old guts of the capacitor, I would highly recommend wearing gloves. So first of all, I like to just remove the wax from the end. And quite often with these older style capacitors, this one's from 1954, the material forming the end is actually starting to decompose and is actually quite easy to strip off. And it actually breaks down pretty easily. Clean away the area. And then using some pliers, start pulling on the lead. And what this does is it starts to disturb it in the core. If the lead breaks off like that, just start poking and prying away at it, being careful not to hurt yourself. Trying to get down to the point where it starts breaking away. At the same time, you don't want to try, or you don't want to damage the edge of the tube here. Try to make sure that you don't mar it. It's makes a little bit harder to replicate the tube in cases where it gets damaged. Sometimes the material is somewhat stubborn and refuses to sort of break down quickly. In these cases, you can try using a hot air gun and heating up the material, and this can actually soften it in some cases and make it a little bit easier to remove. As we can see here, It's now gotten a little gooey inside. It's a little bit easier to take out. At some point you'll reach a core where there's either the coil or the lead is wound into a little pigtail, and it's put at the other side of the plug, or there's a small plate. In this case it's a very small kind of a pigtail that is used to connect to the internal tubular foil. I'll get back once I've gotten the other side off, and then we'll see how to push that core out. Once the end caps have been removed, just take a knife, an X-Acto knife, and clean out the inside edge, just removing any material down to the cardboard, and get all that cleaned up. And then usually you can just push the core out from one side like that. Core comes out, and there we go. Now we have the old leaky core. We can toss that into the garbage, and we can prep the tube for its new replacement. One thing I like to do to clean up the tube is I'll hold this over a garbage can. I'll heat up the outside with a hot air gun and melt the old glue off, and creating a lovely smell in the process. This tends to sort of remove a lot of the old occluded wax from the surface, and means you don't have to scrape it and potentially ruin the artwork on the outside of the tube in the process. A trick here to clean up the outside of the tube and remove a lot of the wax is to heat the wax up until it's soft, and then use a cloth like this one to just wipe down the outside of the tube very carefully and remove the excess wax. It cleans up the tube nicely and gets it ready for the new core. The next step in the process is applying the shield to the capacitors that are going to be going inside. So I've prepared 4 shells here, and so we have 2 0.05s, we have a 0.01 and a 0.1. So I've selected appropriate values from my stock. The 0.05s, it's hard to get that value, so I usually use a 0.047, which is denoted as a 473. This one's not an Illinois capacitor, but I don't think it should be an issue. We can always test it out to see if it's going to work. 0.1s are fairly rarely used in radios. This one I believe was actually out of a test instrument, a VTVM. So as we're applying additional shielding on the outside, I like to kind of guarantee that it's not going to be a problem for the internal wrapping. My guess is this is already Kapton of some type, but I will just add an extra layer of it to make sure we're not actually trying to change the capacitance of the device. In this case, we're just trying to provide a ground shield. Take some Kapton tape and just give it a wrap and cut the tape. It should break free like that. Then just crimp the ends in like that. Just as a side, pay attention to the value of the capacitor that you're putting together, because once you put the copper tape on, you of course can't read the value of it. So in this case, we're putting together a 0.01 core. Next, get a bit of tape, copper tape, and we'll apply that to the outside. You only really need to apply one turn. In this particular case, the capacitor is so small that we don't have to worry about multiple windings of tape. One would be good enough. Now we need to apply the shielding to one side. You can either choose to take some additional copper tape and wrap it around this lead, or what I do in this case is I will take a little wire and I will solder it to the body here and also wrap it around one of the legs. This also gives me a better indication of which side is grounded because I can see that wire. You don't have to go down the entire length of the body, just a little bit's enough. And I first solder it to the lead, and this makes it a little bit easier to solder the other side to the body. Don't apply too much heat. The Kapton tape will help it in this case to prevent damage to the outside yellow foil, but the less heat the better. Just quickly apply it and to get a nice solid bond. And now we have the ground wire on the outside of the foil for a nice connection. If you want to verify the value hasn't changed, we can just use a simple LCR meter here. This one is Bryman, I believe, BM 4070. And I can see it's 10.2 nanofarads. So it's very close to the original value of 10. I like to also mark out the value on this so that I know what it is in case I don't use it right away. So we have 103. I think this was a 600 volt, so 600 volts. So once all the capacitors have been wrapped, we can set them aside and start working on the end cap material, which is the two-part epoxy. And I use a putty that I just pick up off of places like Amazon. It's fairly cheap. Can be a bit messy to work with, so I would highly suggest putting the gloves back on, or you could pre-mix some up prior to starting the wrapping. Don't wait too long, although this stuff does start to harden up fairly quickly after the mixing. And just a side, one thing, if you find that the capacitors are rolling around on you and are very hard to solder, you can just bend the leads like this, and then it's much easier to solder this part onto the shielding. So here's our two-part epoxy. It comes, in this case, it came in a tube, and it's an outer core of hardener and an inner core of epoxy. You don't really need that much. Try to make only a little bit of it, because a little goes a long way when you're making these end caps. Cut some off, reseal the end so it doesn't dry out on you. Pop it back in the tube. And there's a little plastic foil that's on the end of these. Unwrap that. And begin to knead. So I tear it a bit like that. Try to get it mixed as quickly as possible. As you're kneading it, you're warming it up, so it becomes a bit more plastic and pliable. All the while completely ruining the gloves. The instructions on the tube are bizarre. They say to mix this with your bare hands. I would really not recommend that. This stuff is not nice. It's a two-part epoxy. Standard safety procedures with working with two-part epoxies is wear safety equipment. You really don't want this stuff on your skin. Mix it until you don't see any green in the mixture. See, there's still a little bit of green there. A little bit more mixing to go. The trick of this stuff is to make sure that it's all nicely homogeneously mixed together. That way it sets nicely without any problems. Now what I do in this case is that my gloves are a mess. I don't really want to handle the tube with the gloves, because at that point this white stuff comes off on the body of the tube and mars the surface. So what I'll do in this case is I'll actually switch gloves, left to the right, right to the left, and then I have fresh material on the back of the glove. I can use that. One hand holds onto the tube, the other hand forms the ball around the capacitor lead and then sticks it into the tube. So now I take each case and I start to put the core into the capacitor. Of course, this is the black band. That means it's the foil side. That means it's the grounded side. So it goes in this way. Try to keep it centered as much as you can. Then take a small amount of the paste, the dough, the resin, roll it up into a little tube, form it around the lead, and kind of like in a ball, and then push it into the tube. This is where it's really important to use one hand for pushing on the epoxy and use the other hand for holding onto the tube. Don't switch hands. That way you keep the tube clean. The other side, I'll try to make roll it up a little bit smaller. Get it into the tube. Try to use one hand. And then I'll take an X-Acto knife and I'll start pushing it into the tube like this. One nice thing about this epoxy is that you can use water as a smoothing agent. It prevents the epoxy from sticking to the tool, and you can get a nice smooth surface that way. Otherwise it tends to look a little bit jagged. A final finishing move is to just slide the knife around the end, get a nice smooth finish, and then just pick the material off the side of the tube like that. Just get sticky, just dip the blade back into the water. I just cleaned the blade a little bit because it was getting a bit sticky. A clean blade makes the job a little bit easier because it helps to prevent it from sticking. There we go. As a finishing, a final cleanup, we'll go back and clean this up a little bit more and get it a little bit nicer looking. Foil, black end, shielded end. I'm doing this, try to keep the lead centered in the tube. Like that. I'm speeding up a little bit here because the stuff is beginning to harden and it'll get ever more hard to work with, so we just want to work with it while it's still plastic. So I've just using my fingers to smooth it out. I'll come back when I've got all of them stuffed. So I finished restuffing them and applying the epoxy. From the original batch, I've only got a little bit left here, so I timed that pretty good. I've roughly formed the ends. I'm not really worried too much about the final finishing on this. If I need to, I can sand them and smooth them out a little bit if they're a little bit too rough. Similarly, what I'll do once it's dried is I'll just go around the edges with some sandpaper and just clean up this stuff that's hanging over the edge and make it a little bit neater. The final part of this will be to just apply some new wax to them, just to clean them up a little bit and try to restore that sort of that shiny wax appearance. It's not necessary to do this. You can just leave them as is. I just like to sort of put a wax around the end caps to shine them up a little bit and make it hides some of the defects and the boo-boos a little bit. As a side note, you don't really have to worry about reforming the seal at the interface between the lead and the end cap. You don't really have to worry about moisture getting in at all, really, because the capacitor itself is already hermetically sealed, if it's a good one. So I'll let these dry overnight. It's typically 24 hours to get a nice hard finish on them. Otherwise, they tend to be sticky to play around with. If you want to, you can also double check them while they're still pliable and make sure that they still work. So here's a 0.05, it's measuring 46. They are 0.047 caps inside of these. This is also 0.05. And it's measuring, lead fell out. It's measuring 46.7. Here's the 0.1, measuring 104, and the 0.01, measuring 10. Here's some that I've prepared before. These I created about a week ago, and as stated, I actually reapplied some wax to these just to bring the sheen back up, and also on the ends you may see that there's a bit of a shine on the end from the wax. So that's basically it. Not much more to say. The capacitors I usually rework or restuff are not the ones I take out of the radio. I have a batch of old waxies that I keep in a bin, and I'll spend a night just decoring them and putting new cores in and keeping them on hand when I want to do a restoration. In past, I haven't really done this a lot. I may restrict doing this type of restoration to just radios where I want to keep the appearance of the capacitors. I've had one case where a radio really did need to be replaced with the same waxies, with the same size capacitors, because the point-to-point wiring really looked awkward with the newer small size capacitors in there. So I hope everybody's doing well and in these times taking care of themselves. I wish everybody well, and I'll see you soon. Bye for now.